Hello, welcome back. So this is episode 2 where we're going to talk about some ideas that you want to get into and you want to understand before you get into the semester, okay? And in this one I want to talk about converting between degrees and radians or radians into degrees, okay? And like I mentioned before, when you're doing problems out of the book, they're going to use radians probably more than degrees. So it's really to your benefit if you can get comfortable with radians in that in the sense that if somebody says 45 degrees, you want to be able to say, oh, that's, you mean pi over 4. You want to think in terms of radians. I guess it's like a language, right? They always say, like, when you're comfortable in, like, Spanish, for example, if that's not your first language, that you learn English, and then, but if you always have to convert back and forth, you're not fluent in Spanish. You're fluent in Spanish when you can easily think in terms of Spanish. That's what I want you to do. I want you to be able to think in terms of radians. It'll make your life so much easier. I promise. I promise. I promise. Okay, so with that in mind, I'm going to look at this here, and I'm going to talk about being able to convert from one to the other. So that's what I write here. Be able to convert from degrees to radians and radians to degrees. Last video I talked about if you have a full, complete circle, and I'll often write this little line here, meaning that we're always gonna start. This is so typical. This is gonna be like our reference line. And so if we go all the way around here, this angle in radians would be 2 pi. Okay? All right. So I suppose it also stands to reason then that half a circle would be pi, right? Like if I just went from here to here, like this angle up here would just be a single pi, right? And so I can actually break up a couple of angles here that would be easy to pick out. If you go, like I said, a full circle is 2 pi. A half a circle, oh my goodness, a half a circle is just a pi in terms of angles. Here I'm talking angles, so that means that I start here and I go this way. That would be an angle of pi. If I do this, which it really is 90 degrees, right? That would be, well, what's half of pi? Because pi is half a circle. If this is like a fourth of a circle, it'd be pi over 2. Okay, so this one right here, this pi, is actually in degrees would be 180, because you're imagining like a straight line, right? It's like, what's the angle of a straight line? From geometry, remember that? And then this is 90 degrees. Okay, so in there is really the conversion factor. You could actually use either one of these, or you could use the fact that a complete circle is 2 pi, which is how many degrees are in a full circle? That's right, 360 degrees. So either one of these you could use as a conversion factor, and that's how I'm going to recommend doing this. I'm going to recommend this as a conversion factor. You may have done that in geometry. Not just geometry. In Algebra 1, you guys did conversion factors. It's probably been a while, so we'll go over it. I would suggest, I think this one's easiest, because you don't have any fractions, and it's really the simplest. Just a pi is equal to 180 degrees. So let's do a practice problem here with that idea in mind. I'm going to use that conversion factor. Pi is equal to 180. So practice problem number 1. I'm going to say, what if I have let's say 60 degrees. We'll go degrees to radians first. Now I'm going to convert that to radians. How would I do that? Okay. Conversion factors. I'm going to begin with the thing that they give to me. And I'm going to put it over 1. Because 60 degrees over 1 is 60 degrees. And I'm going to multiply it by my conversion factor. I'm going to use this one. I'm going to use the 180 is equal to pi. So in terms of units, I want the degrees to cancel. I want the radians, which is really the pi, I want that to remain. So what I'm going to do is I'm going to write the 180 on the bottom here, and I'm going to write the pi on top. This is my conversion factor right here. This is my conversion factor. They're both equal to each other. Pi and 180 are equal to each other. So in effect, all I've really done is multiply by 1. And you can think about it this way. You can think about the degree units cancel each other out. Degree divided by degree, it's unitless. And then all you're really doing then is you're doing 60 times pi, divide that by 180. Okay? So I'm going to get this. 60 equals 60. The degrees are gone now. Over 180. And then I could simplify this. This 60 and this 80, the zeros can go away. And you got 6 over 13. That's really 1/3, right? So I'm going to write this as pi over 3. And I'm going to put this here for the first couple times, but we should get comfortable with the fact that whenever I see pi over something, it's probably going to be, and it's an angle measure, it's going to be in radians, okay? But I'm going to write it here to start. So that is to say 60 degrees and pi over 3 radians are identical, the same thing. Convert it from degrees or radians. Okay, how about if I go from radians? How about if somebody gives me, this is problem number 2, somebody gives me pi, let's say that's 3 pi over 4, and they want me to convert that to degrees now, because this 3 pi over 4 is in radians. Okay, well, start with what they give you. Start with the 3 pi over 4. Okay, I'm going to multiply that by my conversion factor. My conversion factor was 180 degrees is equal to pi, and I could put the rad, but I won't do it here, pi. And so I want the pi's to cancel, so I'm going to put the pi on the denominator and 180 on top. You see how the pi's are going to cancel? Right, pi up here, pi up there. So in essence, I get 3 times 180 over 4, and that'll be my degrees. Now, I could kind of simplify this a little bit here. So you got 3 180, maybe the 180 and the 4, I could cut those down. So, I don't know, you know what 180 divided by 4 is? Well, let's do it by 2's first here. How about that? So I'm going to divide by 2, divide by 2. So I get 3, and then I'm going to divide the 180 by 2, get 90 over 2. And then, you know, the 90 and the 2, I could divide those by 2 yet again, right? Because they're both even numbers. So 3 times 45 over, and then just 1. So I got to think, what's 3 times 45? Well, 2 times 45 is 90. And then 90 plus 35, 90 plus 45, sorry, I already said the answer. It's 135. 135 degrees. So that is to say 3 pi over 4 is equal to 135 degrees. Okay, let's do another one here. And I'm going to draw a circle for this one here because I want you to see what's going on, why they would do this to us. Okay, typically when you go around, when you do the angles, you're going this way, you're going counterclockwise. It's just the way they do it, all right? They always say go counterclockwise is going to be the positive direction. However, they could easily go in this, which would be called the negative direction, okay? So I'll show you what I mean here. If they give you this, they could say in degrees, for example, let's say it's problem number 3. They could say negative, let's say 25 degrees, and they want us to convert it to radians. Okay, so imagine this. Imagine you're starting here. Instead of going to the positive direction, you're going to go, here's positive direction. You're going to go in the negative direction. You're going to go this way. You're going to go like 25 degrees, roughly here, right? So this is like our angle. They want to know what that would be, the negative 25 degrees in radians. Well, let's begin with what they start with. They start with 25 degrees. I'll put it over 1 times. I'm going to use my conversion factor, 180 and 180 in pi. Sorry, so I'm going to put 180 on the bottom, and I'm going to put pi on top. Okay, the degree signs will cancel because you have one on the top and one on the bottom. So now we have negative 25 pi over 180, and then again we can basically just simplify this fraction here. Negative 25 and 180. So see, I can divide them both by 5. So that would be negative 5 pi. I'll write it out. Divide by 5. Divide by 5. So I get negative 5, and then you know what 180 divided by 5 is? It's going to be 36. And then I think that's really it. That's all you can really do with that one. And then that will be in radians. Negative 5 pi over 36. Okay? So that's what you want to be able to do. You want to be able to convert from degrees and radians to degrees, and it's just using those conversion factors. That's all you really have to do. I would use that one, the pi is equal to 180 degrees. Okay? Awesome. Well, I hope that helps, and I hope to see you in the next video here. All right?